To UPSC high altitude pseudo-satellite vehicles HAPS. The Bengaluru-based National Aerospace Laboratories successfully flew a prototype, a new generation unmanned air vehicles that is being seen a huge technology breakthrough. This unmanned air vehicle is different. It can fly at a great height, about 20 km from the ground. It runs entirely on solar power and can remain in air for months. Such an unmanned air vehicle belongs to a class of flying object called HAPS, high altitude pseudo-satellite vehicles, or high altitude long endurance vehicles. HAPS high altitude pseudo-satellites are meant to fly in the stratosphere region between 70 and 23 km above the Earth's surface. Since the wind speed is very low and ideal for the lightweight aircraft to remain stable, no country has mastered this technology yet. However, this successful test flights show that India has capability like some other countries trying to develop this technology. The possible use of high altitude pseudo-satellite surveillance and monitoring, disaster management. High altitude pseudo-satellite better than currently available technology. Comparison with the drones. Normal unmanned air vehicles or drones are mostly battery power and cannot remain in air beyond a few hours. They fly at relatively low levels, because of which their vision is restricted to small areas. However, it can easily keep an eye over 200 square kilometer of area. Comparison with the satellite in low Earth orbits are continuously moving with respect to the Earth. They cannot constantly keep eye on the target area. Geostationary satellite 36,000 kilometers above the ground can keep a constant gaze over one area, but are expensive and once deployed cannot be repurposed or reoriented. However, high altitude pseudo satellites can be easily redeveloped over another location or can be re-equipped with the different payloads. Engineering challenge in developing high altitude pseudo satellite. The solar power issue. The biggest challenge is to generate enough solar power to keep the aircraft flying, the payloads operating, and the battery charging. The high battery density required. Because of the limitation of the space and weight, solar cells and batteries need to have very high efficiency in terms of the energy density, the amount of energy stored in the battery in proportion to its weight. Design related challenges. Aircraft need to be extremely lightweight to minimize the power requirement, but it also has to stable at the same time. Low temperature. The temperature in the stratosphere can drop to minus 15 degrees Celsius or lower. Electronics needs to kept warmer, and this form an additional burden on power resource. Low air density. Air density in the stratosphere is just about 7% of what is at the sea level. That creates a complication in producing lift and thrust. Thank you. Bye.